Alright, question number 1 says, the graph models the train's distance from a river as the train travels at a constant speed. Which equation represents this relation? We went over this one yesterday. What did we decide was the best answer for this one? C. How did we determine that? What did we do? Put it in our calculator. To get to the absolute value, we went second 0, 60x, and we graphed it. We didn't see anything when we graphed it because that's all we get. So what did I do? What did we do to fix that? Or what did we do instead of that? We went to the table. And what is it that I'm looking for in the table? Well, first of all, I know 0, 0 should be in the table, and it is. It's in there. Is there any other ordered pairs that I know for sure should be in the table? 160 and negative 160. So I check those, and they are there. So that's my verification that I have the correct equation. And what I also did was I put these other ones in there, and did I find that those 3 points were on those other equations? No, they were not. So you need to know that this one has the ones you want. You also need to know these are incorrect, okay? Number 2 says make a mapping diagram for the relation. To make a mapping diagram, you put your domain in a circle, you put your range in a circle, and you draw arrows. Domain and range. The domain numbers are negative 1, 0, 3, and 4. The range numbers are negative 3, 1, negative 1, and negative 6. And then you draw an arrow to show the matching pairs. Negative 1 pairs with negative 3. 0 pairs with 1. 3 with negative 1. 4 with negative 6. So that is number 2. I had a question this morning. They said, well, what if your relation had negative 1, negative 3, negative 1, 4, 3, negative 1, and 4, negative 6? What would you do if, in this case, 2 of your, this is number 2, this is just an example. If 2 of these were the same, I said, well, you would start out with your domain and your range. Negative 1, you only list it one time. You don't repeat it. And then 3, and then 4. And then your range would be negative 3, 4, negative 1, and negative 6. Then you draw your arrows. Negative 1 matches with negative 3. Negative 1 also matches with 4. All they're asking you to do at this point is talk about whether it's map the relation. But eventually we're going to say, is it a function? This would be the indicator that it is not a function because you cannot use x values twice. 3 would map to negative 1 and 4 to negative 6. Okay, number 3. Number 3 says f of x is equal to 5x plus 1. Find f of negative 4. So you just simply put that negative 4 in place of x, and you get negative 19. Did everybody get that? Okay, number 4. Graph the equation. Okay, so to graph the equation, where do we start? The equation says what? Y equals negative 1/4 x minus 3. Where do you start here to graph this equation? Okay. Took care of my y-intercept. From there, what do you do?
Go down 1 and over to the right.
Okay. And there's my graph. Questions on number 4? Okay. Number 5. Number 5 says find the slope of negative 1/3, 0, and negative 1/2, negative 1/2. So what's the formula for slope? Rise over run. So given an ordered pair, what do you think about when they give you an ordered pair? y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And you label. So this is negative 1/2 minus 0 over, and I use that one, and I use that one, negative 1/2 minus negative 1/3. Put that in your calculator. Negative 1/2 minus 0 is negative 1/2. Negative 1/2 minus negative 1/3. Math, enter. Negative 1/6. Divide those. You can do that by hand. You can put it in your calculator. What are we going to get for an answer here? 3. Did you get 3 for number 5? Okay. Number 6. Number 6 says find the point slope form of the equation that goes through negative 6, negative 4, and 2, negative 5. Okay, help me do this one. This is the point slope form. So this is how the answer is supposed to look. What do I need to know in order to... Got to find the slope. So I've got to find slope. So here we go. Negative 5 minus negative 4 over 2 minus negative 6. So in the top, what do you get, Gentry? Okay. In the bottom, 8. So m is negative 1/8. So y minus, what's y sub 1? Negative 4. So when I put it behind the minus, it makes it plus 4. Equals m, I just calculated that. It's negative 1/8 times x minus, which when you put negative 6 behind the subtraction sign makes it say plus 6. That's your answer for number 6. Does everybody get that? Number 7. Number 7 asks you to determine whether y varies directly with x. If so, find the constant of variation and write the equation. You need to make a series of y over x ratios, and if they are all the same, your answer is yes. So we start with 7.2 over 6, 13.2 over 11, 19.2 over 16, and 25.2 over 21. Put these in your calculator. Are they all the same? What do you get for an answer every time?
1.6.
That is your k value. Your equation for this is in the form y equals k times x, so it's y equals 1.2x. So you have an answer of yes, an answer of k, and an answer of the equation. Number 8. The range of a car is the distance r in miles that a car can travel on a full tank of gas. The range varies directly with the capacity of the tank, C, in gallons. Find the constant of variation for a car whose range is 341 miles with a tank of gas that holds 22 gallons. Write an equation to model the relationship between the range and the capacity. So I need to find K. K will be the ratio of y over x. Okay? Well, they don't give me y and x this time. They give me C and R. So which one do I use where?
R could be y.
Okay, so R has what value? 341 over 22. So R over C is going to give me my K value. What's 341 divided by 22? Is it? So 15.5 is equal to the k value. Now when you write the equation, this is what they want the equation to look like. So it's going to look like y equals 15.5x, but they want you to use c and r, so it's going to say r is equal to 15.5c. Okay? Questions on number 8. Number 9. If y is 166 when x is 83, I'm putting this in the ratio y over x, then find y when x is 23. So we need to solve this. We can use cross products. 23 times 166 is equal to 83 times y. What's 23 times 166? Divide by 83. Y is 46. Did you get 46? Okay, number 10. A new candle is 8 inches tall and it burns at a rate of 2 inches per hour. Write an equation that models the height after t hours and sketch the graph. Okay. What would you write for an equation? H is height, t is time. H equals negative 2t plus 8. Okay? What does your sketch look like? Where does this thing hit the y-axis?
0, 8.
Here? At 8, right? The point 0, 8. Where's it going to hit over here? Can you find the x-intercept? When's it going to burn out? Right, when h is 0. When will h be 0?
After 4 hours.
So at 4 hours. So there's your graph. Sketch the graph right there. This is 4, 0. 11. A cannery processed 605 pounds. There's this question about a canary in Algebra 1. That's why I thought it would say canary, because it says a canary's heart rate, blah, 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 blah. Well, that's not what this says. This is talking about a cannery, where we're going to...
Like, I had no idea what canary was. I had no idea what we were talking about. I knew it was a non-human living thing.
We're talking about a processing plant where we're going to can some kind of strawberries. 605 pounds of strawberries in 3.5 hours. They processed 2,100 pounds in 10 hours. Write a linear equation to model the weight of the strawberries as processed in 10 hours, on t hours. Okay, so we've got to find how many strawberries we're canning per hour. So if we were going to graph this, where would we put time and where would we put pounds? And pounds would be here. So time is your x value. Time, pounds. I don't think they said use P, I think they said use S. T, S. So this is how we're going to set this up. So the first pair of numbers that go together are 3.5 hours and 605 pounds. The second pair of numbers are 10 hours and 2,100 pounds. And then you have to find the slope. So what do you get when you find the slope? What's 2,100 minus 605? 1495. 10 minus 3.5 is 6.5. Divide those. 230. So they're canning 230 pounds of strawberries per hour. What's the question say? Write this in what form? Write a linear equation. Okay, so we're going to start with point-slope form. So what goes where? $605. 230 is your rate, or your slope.
3.55.
Okay. Now I want to end up with it looking like this. So what do I do next? And what do we get? I got 805. Did y'all get that? What next? So y equals 230x plus 200. Now if I put the s and the t in there, the number of strawberries is equal to 230 times the time plus 200. That's what they want to see from me.
It's negative with a negative 200.
Yes, it is. Wonder why. Why is that? Takes a little bit to get going. When they walk in, do they immediately start processing strawberries? What do you think they have to do first? Clock in.
Get the can machine going.
Get everything. It takes. Does it take a whole hour to do that? I mean, they're 200 pounds behind at time zero. You understand what I'm saying? Have they lost an entire hour?
No.
How do you know?
Look at the cannon 230 an hour.
They can 230 an hour. They're 200 in the hole when they start. So they're, what do you think? Maybe, let's see, 30 would go into 230. What part of that? 30 over 230. What fraction of it is that?
87% an hour.
Okay, so this is 13%. So 13% of an hour is what they have. 87% is what they've lost. 87% of an hour is how many minutes? How many? 52 minutes. 52.2 to be exact. So it takes 52.2 minutes for them to get everything ready to start. Okay. Now none of that extra stuff was in here. That's just me asking you that. Get your brain. It's bonus. Yeah, you didn't pay for it. It's just above and beyond the cost of a regular Algebra 2 quiz. Oh, you want to know about bonus points? Oh, yeah.
I won't charge you extra.
Yeah, no, the preacher doesn't charge when he preaches past 12 o'clock, does he? No, he does that for free. Okay, here we go. So that was 11. Let's look at number 12. Graph, decide if it's linear, if so draw a trend line, and write the equation. So we're going to graph 12. -1, -2, 1, 3, 13, -4, -3, 0, 5. So what do y'all think? Is that linear? Probably? It's not an answer in math class. Oh. Okay. Yeah, this is my advanced class, isn't it? Y'all are quick here. Okay, so we think it's linear? Yes. So if I had a ruler, I would draw a really straight line, but I'm going to do the best I can. So there's our trend line. Now the next thing you have to do is give me an equation of the trend line. Need an equation of the trend line. Okay. You're approximating that it's going from here to here and calling that 2x. Okay. Plus what? 5. My book has 2.5x plus 5. But when you're drawing a trend line and you're graphing, that's close enough to be the same answer, to be reasonable. In other words, what are we using this for? We're making predictions about the future. Are these predictions going to be accurate? No. If our dots lined up in a perfect line, it's still a prediction. It might or might not happen. So that's number 12. 13. What does 13 say? Graph the absolute value equation. How are you going to graph that one? What's your strategy on 13? Type it in the calculator. Let's do that. Y equals second 0 x plus 4. What does the 4 do on the inside?
This is positive. It's going to move it on the x-axis to the left.
Going to do the opposite of what you would expect. It's going to move it to the left. And so I would choose the correct, this is multiple choice test tomorrow, and I would choose the correct picture where it's going to hit over here. Write two linear equations used to graph y equals x plus 7. Okay, what did you do on that one? Strategy on this one. Well, let me ask you this question. What if I told you that y was equal to the absolute value, let me back up. 9 is equal to the absolute value of x. What do you know about x? It's this or it's this, right? So if y is the absolute value of this, y is either equal to that or y is equal to the opposite of that. Same process. So y equals x plus 7 is one of my linears. Distribute here. Y equals negative x minus 7 is the other. So that's how you get the two of them together. Now, before you make that decision, before you split it, make sure that you have the absolute value bars isolated. Okay? 15. The equation y equals negative 2x minus 1 describes a function that is translated from a parent function. Parent functions are the most basic of each type. So the parent function for this would be what? What's the parent function? Y equals x is the parent function. Okay. Write the equation of the parent function, 15a. Y equals x. And then find the number of units, the direction of the translation. How far are we away from that? I'm gonna graph it. Y equals x. Can y'all see what I'm doing here? Is this line. I'm going to graph this one. Negative 1 down 2 over 1. This line. How far are we away from that? How far away are our points? At some point they're really far?
Yeah, I mean.
Yeah. Okay.
Way down here, it's pretty far from this one.
For this problem, in order to answer this part, I'm going to back up and talk about parent functions again. Let's use this for the parent function. If I were to use this as the parent function, how far would the points be apart? How far apart would they be? To describe, let me back up. Describe the change. The original one would be this way. You're good at talking, Gentry. Come on, come up with the answer. Describe the translation. Down 1. That's all they did was moved it down 1. Okay. Now, I'm going to tell you that the parent function for linear is this right here. This is the parent function. For this question, they're wanting you to just describe it using this. But for the rest of your mathematical career, parent function of linear is y equals x. And parent function for quadratic is y equals x squared, and so on like that. 16.
Go.
Write the equation. Okay, let's look at 16. Write the equation for the horizontal translation of y equals absolute value of x. How far did this move from y equals absolute value of x? I mean, if you graphed y equals absolute value of x, it would look like this, right? And what happened to this one?
Went 4 units to the right.
It's moved 4 units to the right. So what would you do to the equation? Inside there or outside? Inside. Let's verify. Y equals, all I gotta do is change that to subtract graph. Did that work? Yes. Okay, so we've translated it 4 units to the right. 17 says, the equation y equals negative absolute value of x plus 5 describes a function translated from its parent function. Now on 17, let me tell you what the parent function is. The parent function is, this is what they're wanting you to use for the parent function, y equals negative absolute value of x. Okay? Now what does the negative do? It flips it upside down. Find the number of units in the direction of the translation. So we're flipped upside down by the negative. We have the negative in both the parent function and the one they're questioning about. So that's not the change. The change is the plus 5. What does this do when you put the plus 5 in it? Moves it 5 units to the left. And this would be the original, and this would be the second function. Okay. 18, graph this function. When you put that in your calculator, describe what's going to happen.
18
Mm-hmm.
will be 5 units to the right, and then 4 below that x-axis.
5 units to the right, so it's going to do the opposite of whatever happens in here, and then 4 units below. It's going to do exactly what you expect for this. So that is your 18. 19, graph the inequality. What do you have to do before you can graph this inequality? No matter what your strategy is, what do you have to do to this? We're going to solve for y. So I'm going to subtract 4x. Negative 2y is less than negative 4x minus 3. I'm going to divide through by negative 2. What's that going to do to this?
Well, change the direction.
From this way to this way. What's negative 4 over negative 2?
2x.
Plus 3 over 2, which is 1.5. Now, you have several strategies you can use to graph this, one of which is the calculator, as long as what's on. What do you need turned on? Inequalities. So we go to y equals, and we change it. We don't need an equal sign. We need a greater than sign. So I hit alpha and that button. I'll change that over, and I get 2x plus 1.5, and I graph. And what kind of line did it draw? A dotted or a solid? Dotted line, and it shaded above the line. Any questions on 19? 20. An electronics store makes a profit of $20 for every portable DVD player sold, $45 for the DVD recorder sold. The manager's target is to make at least $180 a day on sales. Write and graph an inequality that represents the number of both kinds of DVD players that can be sold to reach or beat the target. P is the number of portable, R is the number of recorders. How much money are we making on the portable?
$20.
Profit's $20. Every time I sell one, I get $20. Profit. How much profit am I making on the recorder? If I add all my profit together, I want it to be at least $180 a day. What does that mean? I know there's going to be 180 over here, but how do you show at least? Greater than or equal to. Does it ask us to graph? Yes. So when you graph that, P is on the x-axis, R is on the y-axis. You would take this equation, instead of solving for y, solve for R, because that's what's on the y-axis. Okay? So it's 45R greater than or equal to 180 minus 20P. I'm going to rearrange that when I divide. R is greater than or equal to negative, what is that going to be? 4/9. Check my math. What's 180 over 45? I think that's 4. Is that 4?
4.
Okay. So, there's our graph. Starts at 4, goes down 4 over 9. We want the R to be greater than or equal to, so our line is solid. 21, graph the absolute value inequality. Go to y equals. You still need inequalities turned on. We want it to be less than, change it to less than, enter the absolute value, x plus 2 minus 2. And when we graph, it's a dotted absolute value graph, so it's a dotted V with shading below. 23, write an inequality for the graph. This will be difficult to do unless you've looked at your y-intercepts and all that. Tomorrow will be multiple choice. This one is y is less than or equal to absolute value of x minus 3 minus 1. Let me write it so you can read it. Is this relation a function? Explain. Tell me your answer to that one.
No.
Tell me why.
Because negative 1 is used as an x value.
Okay. So basically, these are the numbers I'm focusing on right here. And when I checked this one, I had enough information to say no. Because that was the first time anything had been repeated. That was enough. The fact that those two were used more than once is enough to say no, it is not. You cannot repeat x values. Now they went ahead and repeated it 3 times, and then they went ahead and used the negative 2 again as well. But you really could have said no at this point. You didn't. The rest of them are not what causes it. It's just the fact that 2 of them are repeated. Write an equation of a line that contains this point and it's perpendicular to that. What do you need to know from the perpendicular line? What's important about that? What do you know about perpendicular lines? Nothing? What do? Do they touch? They intersect and they form right angles. And we study them when we study parallel lines, right? And parallel lines do what? Never touch. There's something to do with slope that's important about parallel and perpendicular lines. Parallel lines have same slope, and perpendicular lines have flipping opposite or opposite reciprocal slope. So if I know the slope for this line, I need to flip it to find my new slope. Okay? So let's find the slope here. It says 4x minus 3y equals 10. Solve for y. Subtract 4x from each side. Negative 3y equals negative 4x plus 10. Divide everything by negative 3. Y equals 4/3 x minus 10/3. That's the slope of that line. I need a new slope. What's my new slope going to be? Negative 3 over 4. Now I'm going to take the new slope and the point they gave me to write my equation. So it's y minus negative 3 equals m times x minus 8. What are they asking us to do? Write an equation in standard form. They want to graph the equation, write it in standard form. Okay? Well, graphing it's easy. I could graph it before I ever wrote the equation for it. I know that it goes through the point 8, negative 3. Oh, right there. Okay? And that it has a slope of 3/4. That's enough information to graph it, right? Then they want me to write it in standard form. What does standard form look like? Y'all remember? So I've got to distribute. 4 goes into 4 once, goes in there 2 times. It's going to be plus 6. Subtract the 3. No, I don't need to subtract the 3. What am I doing? Well, the standard form won't have any fractions in it. So what do you do to get rid of the fractions? Multiply 3 by 4. So 4y equals negative 3x plus 12. Then what do you have to do? So finally I get 3x plus 4y is 12. That's your final answer. Last question. Describe the vertical line test for a graph and tell how it can determine whether a graph represents a function. What do you think? Does a vertical line check to see if something's vertical? No. No. A vertical line does not check just to be sure it's vertical. That's what you would think it would be, right? If you do, if you take an art test to see if you can do art, right? If you test your vehicle, if you do a battery test on your vehicle, you're checking to see if the battery's good. But a vertical line test does not check to see if something's vertical. That's a misunderstanding. What it does is it checks to see if it's a function or not. For instance, if I have these points, 1, 1, 2, 5, 3, 8, 1, 1, 2, 5, 3, 8. If I take a vertical line and I slide it across, does the vertical line touch 2 points at the same time? No. Then, yes, it is a function. Okay? They might not give you points, they might give you a picture. They might give you a parabola. Now you know I can't draw, but that's supposed to be a U-shaped graph. Is this a function? Does the vertical line touch it twice? No. So this one's yes. What if I turned that and I had it looking like this? Is this a function? No. Okay, that's what the vertical line test does. Because if it touched twice, that means that at x is 1, I have 1 comma 4 and 1 comma negative 1. You see what would happen if it touched it twice? And that goes against the rule I have about using an x value more than once. That ties it all together from whether I give you a list or a mapping diagram or a picture. You're able to tell if it's a function or not. Okay. Y'all have any questions?
That parabola thing,